You've probably heard about Apache Kafka, and you know it's used by companies such as Uber or Netflix. But do you know what it really is? In this video, I will break down Kafka in simple terms and show you how it works under the hood. My name is Matúš. I am a senior software engineer with more than 7 years of experience, and I spent past 3 years working on projects that use Kafka messaging. Let's start with what is Apache Kafka. Apache Kafka is distributed open source event streaming platform used to build real-time data pipelines and streaming applications. In simple terms, it's a system for moving data between services or systems in real time, very fast and very reliably. For example, think about Uber. Every time a driver moves, Kafka streams information to multiple systems. One updates the rider's live map, another recalculates estimated arrival time, and another adjusts dynamic pricing. All of that happens instantly, powered by Kafka, handling these millions of messages every second. By the way, some of you might be wondering why it's called Kafka, such as the famous Czech writer Franz Kafka. Well, one of the founders was actually fan of the writer. He thought the name was fitting because, just like Franz Kafka, the system writes a lot. Kind of poetic, right? Now let's look at the architecture of Kafka. Let's start with high-level explanation of Kafka architecture, and then we will move one level deeper. There are 4 main building blocks for Kafka architecture: producers, consumers, brokers, and topics. Producers are applications that send messages to brokers. Brokers are servers that store the messages, and consumers are applications that pull messages from the brokers. Topics represent different communication channels over which messages can be sent and received. Now, let's take a look one level deeper and see how Kafka works under the hood. Kafka follows distributed architecture designed for high throughput, fault tolerance, and scalability. First, let's understand the main components. Producers are applications that send messages to Kafka. Each message has key and value, and producer is configured to send it to a specific topic. Based on metadata received from Kafka cluster, such as list of brokers, partitions, and topics, producer calculates partition for a given key and sends the message to a broker assigned to that partition. Topic is like a named channel or stream. All related messages, such as all other events, go to the same topic. Internally, each topic is split into multiple partitions. Each partition is an ordered log, where each message is identified by offset, where messages are stored sequentially and identified by unique offset. Partitions are identified by indexes. Kafka guarantees that messages in the same partition stay in order, but there is no ordering between partitions. Partitions allow parallelism. More partitions means more consumers can process data simultaneously. Broker is a Kafka server that stores partitions. Typically, you will have multiple brokers, each responsible for a subset of partitions. One broker acts as a leader for a partition, and others are followers that replicate the data for fault tolerance. If a leader fails, the follower automatically takes over, ensuring high availability. All brokers together form a cluster. The cluster manages data replication, partition leadership, and topic and partition metadata. This management is done by cluster controller. What is in new versions of Kafka handled by internal server called Kafka Raft controller. In older versions of Kafka, this was handled by external server called Zookeeper. Consumer and consumer group. Consumers are applications that read messages from Kafka. They use pool model, which means they periodically poll brokers for new data. Each consumer tracks its offset, so it knows exactly what message have been processed. Offsets are also stored on broker side allowing reliable message processing and recovery after restarts. A consumer group is a group of consumers that share the same group ID. Kafka ensures that each partition of a topic is only consumed by a single consumer from a group. This allows scale out of message processing by adding more consumers. In such case, Kafka automatically balances load across them. If one consumer crashes, another in the group takeovers its partitions. Consumer app know its consumer group ID, topic to read from, and polling configuration. A Kafka cluster gives to the consumer list of partitions that it should read from and list of brokers that holds the partitions. Maybe the question you are asking yourself is why to use Kafka? So why do so many companies such as Uber or Netflix use Kafka? Let's break it down to key reasons. First, Kafka is fast and scalable. It can handle millions of events per second, and when you need more capacity, you just add more brokers. So no need for redesign or downtime. Second, Kafka is reliable. Messages are written to disk and replicated across multiple brokers. So even if a server goes down, your data are safe. And the third, Kafka decouples systems. Producers and consumers don't need to know about each other. They just read or write to Kafka, which makes system easier to evolve and scale independently. Now we know what is Kafka, how it works, and why to use it. Hit the like button if you learned something, and subscribe if you want to keep learning. Thanks for watching, and see you in the next video. Bye.